Welcome back to Arxflix. Today, we're discussing a groundbreaking paper titled Soaring from 4K to 40K, Extending LLMs Context with Activation Beacon. This paper introduces a novel method to significantly extend large language models, LLMs, context window from 4,000 tokens to 400,000 tokens without drastically increasing computational costs. Long contexts are crucial for tasks like retrieval-augmented generation and in-context learning. However, typical LLMs like LLMs are constrained by fixed context windows, 2K for Llama 1 and 4K for Llama 2, which can be insufficient for handling real-world scenarios. Fine-tuning to accommodate longer contexts can be costly and might degrade the LLM's performance on short context tasks. Activation Beacon is a new method designed to condense the LLM's raw activations into compact forms. This approach allows the LLM to perceive and process much longer contexts, even with limited context windows. Let's visualize this concept. Here, we see the beacon token, Langle text beacon wrangle, appended to a context, prompting the LLM to condense the raw activations. These condensed activations are then processed streamingly using a sliding window approach, making the method memory and time efficient. Rather than developing a new model from scratch, Activation Beacon leverages the existing LLMs by adapting their strong context representation capabilities. Special beacon tokens prompt the LLM to condense contextual information. Activation Beacon introduces new, specialized self-attention parameters to support this process without modifying the original LLM parameters. In practice, beacon tokens are appended to the context, and the model produces condensed activations which encode vast amounts of context. The context is processed using a sliding window approach, partitioning long contexts into manageable intervals. The sliding window sequentially processes each interval of the long context. This method ensures low memory consumption and linear time complexity, while accumulating contextual information from past tokens. An autoregression task trains Activation Beacon by maximizing the generation likelihood of each token based on the preceding tokens and beacon tokens. This figure illustrates the transformation of raw activations into compact activations of beacon tokens, which the model can then use to generate future tokens. Different attention schemes are explored to optimize this process. Activation Beacon has been applied to Llama 2 7B, significantly extending its context length from 4K to 40K tokens. Training on a mixture of red pajama and long alpaca datasets, the method achieves superior language modeling and context understanding performance with minimal training cost. The perplexity comparisons show that Activation Beacon outperforms other context extension methods such as position interpolation and NTK-aware scaled rope, illustrating better long context generation quality and running efficiency. Unlike traditional methods that may require extensive fine-tuning, Activation Beacon introduces a plugin module, preserving the LLM's capabilities in processing short contexts. It ensures high running efficiency, both in terms of GPU memory and inference time. Additionally, when combined with other techniques like position interpolation and NTK, Activation Beacon can further extend the context length to even 1 million tokens. Activation Beacon offers an efficient, compatible, and low-cost method to dramatically extend the context length of LLMs. It retains the LLM's capabilities in short context processing, while enabling high-quality generation and understanding in long context scenarios. This innovation opens up new possibilities for AI applications requiring extended context without heavy computational demands. That's all for today's video. If you found this summary helpful, please like, share, and subscribe to Arxflix for more insights into cutting-edge research. See you next time. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.